BYD launched its Megawatt Flash Charging technology at the Super E-Platform Technology Conference on March 17, 2025. This technology achieves the highest charging performance among mass-produced passenger vehicles globally, with specific parameters including a maximum charging voltage of 1000 V, a maximum charging current of 1000 a peak charging rate of 10 C, and a maximum charging power of 1 megawatt. According to BYD Chairman Wang Chuanfu, its peak charging speed reaches 2 kilometers per second, with a 5-minute charge providing about 407 kilometers of range. This speed rivals the efficiency of refueling a gas car, marking a significant breakthrough in electric vehicle energy replenishment. Additionally, BYD plans to build over 4,000 megawatt flash charging stations nationwide to support the widespread adoption of this technology. Megawatt flash charging is a breakthrough worth celebrating, greatly enhancing user experience. It reduces electric vehicle charging time to a level comparable to refueling a gas car, completely alleviating range anxiety and charging wait times. This gas-electric parity replenishment efficiency could change consumer perceptions of electric vehicles, encouraging more people to switch from gas cars to electric ones and accelerating the market penetration of new energy vehicles. While BYD's current application may involve some hype, it has indeed seized the industry lead and demonstrated a practical solution to eliminate range anxiety in electric vehicles. With technological iterations, it's likely that within a few years, electric vehicles will match gas cars in rapid energy replenishment. This move by BYD will also intensify competition in the electric vehicle sector. Through its independently developed kilovolt high-voltage architecture, flash charging batteries, and liquid-cooled supercharging systems, it showcases the technological leadership of Chinese automakers in electrification. This not only solidifies BYD's position in the global new energy market, but may also force competitors like Tesla and XPeng to accelerate their high-voltage fast-charging research, driving overall industry progress. Notably, Tesla has strong technical reserves in energy storage, but it has indeed fallen behind BYD in battery and charging technology. Musk might need to focus less on politics and more on improving products. Tesla is the cornerstone of Musk's wealth, and any issues there could collapse his entire business empire. BYD's plan to build over 4,000 megawatt flash charging stations shows it's not just focusing on the technology itself, but also building a supporting ecosystem. This solar storage charging integrated station design reduces grid pressure and improves energy efficiency, offering a viable solution for large-scale supercharging networks. The traditional model of adding charging piles to gas stations will face challenges, making large-scale retrofitting inevitable. This will significantly advance infrastructure development and create new economic growth opportunities. After all, electric vehicles have gained widespread recognition for their user experience. If range anxiety can be resolved with fast, anytime recharging, they will win market favor and strong government support. China has been pushing for the full electrification of its energy system, aiming to quickly reduce dependence on oil and natural gas. This will not only greatly enhance China's energy security and lessen reliance on the Malacca Indian Ocean route, but also make significant energy cost reductions possible. The cost of solar and wind power in China is already lower than coal-fired power. Widespread adoption of storage stations could greatly improve grid stability and reduce power waste. Meanwhile, China is heavily investing in hydropower. Beyond provinces rich in hydro resources like Sichuan, Guizhou, and Yunnan, the government has begun implementing the Yarlung-Zhongbo River hydropower station. This project is expected to generate several times the power of the Three Gorges Dam, becoming the world's largest hydropower station. As the EU raises environmental standards, many factories on China's coast have moved to inland cities like Yibin in Sichuan province, where cheap green power is available. Whether the U.S. acknowledges it or continues supporting climate issues, it must face unavoidable real-world emission reduction pressures. China is already leading the way. At the same time, China holds a global lead in nuclear power. In small reactors, China's Linglong 1 is the world's first small reactor to pass international safety certification. In even smaller microreactors, China's technology is on par with the US. In fusion reactors, which could potentially solve humanity's energy needs, China keeps pace with the US, each with its strengths. Over the next 2 decades, nuclear power as baseload energy, supplemented by green sources like solar, wind, and hydro, with nationwide storage stations as buffers, will form a highly cost-effective power supply system, providing competitive energy for Industry 40 and the AI sector. The continuous breakthroughs by Chinese companies like BYD are increasing pressure on American firms like Tesla. This highlights a trend. U.S. companies often pioneer new technological directions, but once products hit the market, Chinese firms quickly overtake them in engineering. Musk himself has a deep understanding of this issue, as Tesla's Shanghai Gigafactory was a key factor in Tesla's rise. Under Trump's leadership, the U.S. government is obsessed with trade wars, tech wars, and extorting allies. It might be time to wake up, improve infrastructure, and provide a better environment for businesses instead of constantly blaming other countries for taking advantage of the U.S.